Yes.
All right, let's get started. So thank you all for attending. And today we are delighted to have Dr. Chen Zhong from UCL. And so first, let me give a brief introduction to Dr. Zhong. And Dr. Zhong is an associate professor of urban analytics at the Bartlett Centre for Advanced Spatial Analysis at University College London. She also holds a fellowship at the Alan Turing Institute and a visiting research fellowship at the Center for Urban Science and Progress London at King's College London. Her current research agenda focuses on urban mobility with strengths developed in the use of emerging big data and advanced spatial data science methods, addressing broad transport-related issues in the context of urban development. Her ongoing research projects are funded by the European Research Council and the Economic and Social Research Council. So today, her title of the presentation is Exploring Socio-Spatial Inequality in Urban Mobility. And without further ado, let's welcome Dr. Zhong for her presentation.
Thank you. Thank you for your introduction. Should I share my screen?
Yes, go ahead.
Okay.
So during the presentation, please feel free to type your question in the chat, and we'll be answering questions at the end of her presentation.
I need to apologize. There's something wrong with my setting. It doesn't allow me to share.
Are you using Mac?
Yes, I'm using Mac.
Yeah, I think if this is the first time sharing, you need to probably disjoin and then enable the permission and then rejoin Zoom again. Yeah, don't worry.
Yeah, I'm trying to get Zoom. I will try see if it works now. Okay, desktop share. Preferences and access. Okay, just a moment.
Yeah, please wait for another minute or two. Dr. Zhong is rejoining, so she'll be able to share her screen after she rejoins. And let me set you.
Is that host disabled participant screen?
Let me see you. Yeah, you should be able to do it now.
Yeah, it works now. Let's find this PowerPoint. Okay. Can you see my screen now?
Mm-hmm.
Really apologize. I used to use Teams for presentations most of the time, so
yeah.
Really it's the first time I'm using Zoom on my laptop. Okay, so let me get started. The title of this talk, Exploring Socio-Spatial Inequalities in Urban Mobility. So about the credits, my name is on the first, and I also put our research fellow's name. Chili is the research fellow working on this project, working on those parts of the content in these presentations. And also some of the content is from our urban mobility research group. So I really want to give credits to them. So I put all their names there. I understand that this is an educational webinar. So I think apart from research, people also, audience may maybe also want to know some of the education or research opportunities or even work opportunities. So I don't know why the other speakers didn't do it, but I decided to do it here to introduce the programs at CASA here. we run research lead teaching program, is master students programs. We have 3 there. The first 2, spatial data science and visualization. The second, smart cities and urban analytics, is really strongly relevant to my talks today. Many of the machine learning methods, Geo AI methods, we covered in our modules. If you're interested, want to learn something, you can look at these programs. Also, we have research degrees, PhDs, like we have PhDs in advanced spatial analysis. The last part I really want to advertise is that we really welcome visiting researchers here at CASA. You can come here through the general program, is UCL's affiliated academic scheme. And the second one, ESRC, international arrangement, is linking to one of my ongoing projects that I'm mainly working on. If you Google my website, you can find it. It's Real Trips. And there, if you are holding funding in your own countries, we can easily get this visit arranged, and we have a good case to waive your bench fee. So those are opportunities you can look at. And follow on, this is about the introduction of CASA. Follow on, I want to introduce my little group here. We really have a research focus on urban mobility, and we're interested in emerging human location data. Many of the data sets I don't have to introduce because it's already covered by the previous 3 talks there. And we have our methodology is really focused on analysis and modeling and machine learning, and recently mathematical modeling. We look at cities all around the world, and some of the case studies like Singapore, Shenzhen, you probably have heard it from, for example, Dr. Chen Zhong's talk. That's kind of normal because we even have collaborations together for different cities. And our research themes, from very basic urban mobility patterns to urban indicators to inform urban planning and transport planning, from strategic plan to more local and street level planning. And we also focus on some social impact, social events, like for instance, urban regeneration, urban redevelopment, and we compare cities in different contexts. And I have to say many of those are kind of overlapped with the talks given in the past 3 or 4. And today we won't talk about like network community or spatial structures, which has already been covered. We will have a focus on mobility patterns and how to use it to address the social spatial inequalities. And this topic will be reflected in, will be exampled by our 2 research projects. You can see so you'll be in 3 parts. I'm trying to introduce it in 3 parts. The first part is about accessibility measure, which we use. This method we used in our RESOLUTION projects. That is our first project looking at these inequality problems. It's already finished, completed, and then we have our follow-up projects, which use using more, I won't say more advanced, I would say it's new methods, which is more about machine learning and big data mining, data-driven methods. The final part will be an outlook to introduce our research agenda and other relevant research going on in my team, and just in case you're interested or even want to join us. There are some, I put the full name of the projects there, and also some papers that's already published or in review. If you are interested, you can Google and find it yourself. I will introduce a bit in my talk, and you can also contact us for details. So the research background, why we're looking at social spatial inequality, because it's a really important topic. Of course, all the topics we're researching are important, and this one is particular. I think this image, if you have attended the previous talks, this image you should be familiar with this image. This photo was taken for the purpose of city celebration. So they basically take the photo from the helicopter. When they first taken it, the photographer didn't expect this photo to be so famous, but afterwards it becomes really popular as an illustration of social inequality. I mean, can you imagine really this kind of slums on the left side is really a neighborhood next to a luxury apartments with swimming pool and also kind of tennis court. So it becomes really a clear illustration of the divided society of this segregation inequality problems. Here we define social spatial inequality as the uneven distribution of resource across different locations and also very important population groups. And this actually very critical topic and becomes even more critical in recent years because COVID-19 has I would say deepened those inequality problems, hitting the poorest and most vulnerable communities the hardest. It is really making the inequality groups even more unequal. So it's become so reducing inequality and build more inclusive society is one of the sustainable development goals globally. It's kind of influenced or originated from that image in Sao Paulo. In the first project, RESOLUTION, Resilient System for Land Use Transport, this is our first project. We want to specifically addressing this inequality problem from the perspective of accessibility and segregation. So we are not trying to tackle all kinds of inequality problems. I know there are many like income and also healthcare inequality, all kinds of. We're particularly interested in mobility related. We want to, because we know there are transport infrastructures building everywhere in developing countries, also developed countries. And this transport system, if we plan it in a very good way, it could integrate to space, like making people closer to each other and making your life more convenient. But if you only consider certain locations or certain population group, it will divide the society even more. So we want to know if there are equal access to transport on different social groups, and we want to know if different social groups are locked in or out of opportunities. It's kind of very straightforward. We get to the keywords accessibility to measure the access to opportunities. So it's a very lateral way of thinking. It's a very lateral choice that we use accessibility measure. And particularly we use location-based potential accessibility. I can't really see the time here. So if I'm taking too long time, maybe you can give me kind of a shout, and then I will speed up or something.
You are good. It's 9:15, so don't worry about that.
Okay, I have a lots of slides to show, so maybe I should speed up. Okay, so the location-based potential accessibility, this can be seen as measuring the potential for interactions. It's not a new invention, actually. It has been used for years. As you can see, the reference here are from like decades ago. It's very easy to use. It has various forms of measures, starting from very simple form of cumulative accessibility. If you change, and all these variables can be changed can be further defined. For instance, for distance between locations, cost metrics, you can use the geographical distance, you can use travel time, you can use monetary travel cost, and in terms of transport mode, you can use the road, public transport, walking, cycling, like all kinds of. Even even with these very simple forms of, mathematical forms of measure, by changing those kind of variables, by further decompose those kind of components, variables, we can develop a disaggregated measure out of it. We can do a more fine measurements of accessibility of subpopulation groups. And these subpopulation groups can be defined by, for instance, income, occupation, or their preferred travel modes. And we assume that each subgroup may behave differently in terms of travel and location choice. And from there, we can quantify the social disparities between groups. And like what I'm demonstrated here, you can see that we can see that using different travel modes, like the functions, the distance decay functions in the very simple measures can be different. And here we use different settings of deterrence functions to represent the behavior of different social groups. This gives us the base for the very simple type of disaggregated measures. With that, I would show you an example we did with London. There we try to ask a question which is about who benefits from the development of the metropolitan area. And you can read, this has already been published, and the title of the paper is actually the research question of this particular study: a compact city for wealthy or everyone. So there we apply these disaggregated measures to, there we disaggregate the occupation groups by manager, professionals, like associate professionals, admin, basically. And we refer to another survey. Basically, all of these different types of occupations represent different income levels. From 9 to 1 is from lower income to higher income. And then we also disaggregated by different transport modes, because like different group of people, they have different preference of travels. And we really disaggregated by car, by public transit, by walking, cycling. And of those, you can see that they have, even by this just exploratory analysis, they have different average travel distance and also the spatial distribution across the space. And in the second part, we calculated their accessibility using the very easy one. It's an initial step. We use the cumulative accessibility. And the reason is that because it's very easy to interpret. We found out between different transport modes, car accessibility is actually relatively equal between occupation classes, which means that either you don't have a car or you have a car. If you have a car, your car accessibility is pretty much the same. But public transit and active travel, like walking and cycling opportunities, has significant inequalities. Favoring professional classes, or other ways, like favoring higher income groups. And as you can imagine, those professional groups or higher income groups, they occupy the best locations in the cities. Basically, all those result from the continuing inner city gentrifications, like the city become more compact. Many things are built in inner London, and those areas have been gentrified, means that the middle class, the higher income people coming here, taking the best place, and the people who couldn't afford these areas have to move out. So they has kind of accelerated the inequality problems in London. So a summary of these projects, we found out survey data are most often used for this type of research because it contains very good socioeconomic details, allow us to do disaggregated measures, compare different social groups. However, most of the time survey data are not updated. Like in London, we do the census, very complete census every 10 years, or incomplete. This happens in Sao Paulo. When we want to do a comparative studies, we find it's really difficult because they don't have a complete data set, especially in the SNAM areas. Accessibility, it could come in various forms, and it's very simple, but still is very powerful. And the simplest one works the best, like what we presented in our paper. Cumulative measure is really the basic, very simple one, but they are the easiest one to interpret. And when we talk to politicians, and it's really easy for them to take the idea. And the subgroups and subgroups is most of the time defined based on expert knowledge. So it varies case by case with bias, human bias. Complexity of human behavior is not well captured because we can only do location based, and we have limited categories of like behaviors or attributes. The OD flows and distance measures represents only pairs of origin destinations for single trip purpose. There's no such thing as trip activity chance. So there are advantage, also disadvantage. How can we overcome those kind of disadvantages? So we were thinking about new data, individual level data, trajectory, and then we are thinking about new methods, geo AI, spatial data science. I think this kind of summary and this kind of thoughts really is a good example of current revolution in the GIS domains. Like the computational methods and big data has transformed our GIS domain into a more comprehensive interdisciplinary domain, allowing us to do more things. Therefore, in the second project, SIMETRI, is still ongoing, running from 2019 to 2023 there. Our focus changed. We want to develop new analytical tools respect to mobility accessibility for the Great Bay Area, incorporating new methods or models, and really reflecting machine learning, this kind of new techniques there. And also it's very good case study areas. The Great Bay Area has very rich data sets, allows us to test many of the new ideas, new things. There we don't really use census data because normally the census data at that fine level is very sensitive and really hard to get. And we have talked about the disadvantage of service data before. Here we focus on new data like smart card data, like mobile phone data, social media data. I think Dr. Shu Yang and Dr. Mingshu has already introduced this kind of basic data type before, so I won't say that much. The benefits of this data sets before, in old days, like last century, we can only talk about the concept of space-time. But nowadays, with this data, we can really reconstruct very fine level human trajectories and with location and time tag. There, we can look at not just pairs of trips from A to B for single purpose. We can really look at people's trajectory, which is the trip activity chain of individuals. Also, it reduces the bias and captures complexity of human behavior. Why? Because in my previous methods of accessibility, we have to define n number of groups by expert knowledge. And there's no absolute answer. It all depends on our decisions. And by here, we don't really have to give the preset number of n. We can just leave it as it is, like really looking at individuals, compare individual differences, like capture the full complexity of human behavior. So to demonstrate this kind of advantage, I show a case study we did in Shenzhen. Yes, it's another case study in Shenzhen. Shenzhen is very good place, I mean, for those type of studies, because it's a typical city and rapid development. Is shown here, as you can see here on the left side, is a photo taken from my partner's office at Shenzhen University. I visited them almost every year. Like in 2014, from that window, nothing is really there. And in 2016, those kind of high-rise buildings are built there. One of those buildings, I think, is for Pension. So it's really attracting talents from everywhere. And on the right side is their metro network, and basically they try to extend or open a new line each year. As they open the lines, parts of the city will be connected, and the hotspots will change the people's usage, and you find some areas have been linked together, some areas has been separated to another bigger communities. So the change is really visible, and the data is there allowing us to look at it. So the the consequence of rapid development, we know there are advantages, like economics will develop and people got jobs there. But also in the past 10 years, the income level has increased a lot in Shenzhen, as well as the housing price, and as well as the inequality problems there. So here in this research, we are trying to use smart card data to address, in terms of public transit users, what's the relationship between socioeconomic status? Here we specifically referring to income and their mobility patterns. Is there any difference between different income groups in terms of their residential location choice and daily activity choices? So the data sets we're using to reconstruct people's trajectory is the public transit data, including, sorry, there's a typo there, including bus and metro. We have 1 week data from November 2016 there. You can see that basically we have pre-processed the data to form a complete trajectory trip activity chance of every individual, because the stations are so densely distributed. If we combine to the nearby point of interest, we can kind of tell, like, this guy at this time is going to a bus stop, I mean closing to this kind of shopping mall, apartments, or it's their high tech, their working place, or kind of something. We defined 2 ways to represent mobility patterns. One way is to quantify the mobility patterns by indicators. So those indicators are not invented by us. Actually, it has been used in many previous work. We define certain of them here, and we also need the literature review, try to borrow some of the ideas from the other research in mobility patterns. So you may find familiar with these activity features there. And then we define another type of another way of representing mobility patterns, which is to use the raw trajectory as a graph. So we have the stops, and we have the link between stops as a move. So you can, when you accumulate them by time, so you decompose them by time and then aggregate them by areas together, you can have this kind of images there. You can have this time series images to really represent the kind of mobility patterns from there. So we have these 2 types of representations. One is by indicator, one is by this graph. Why we're using this raw trajectory? Because we're thinking the indicators, even though there are many, but still we have a limited number of indicators, we may not be able to capture the full picture of the patterns. We only capture those what we defined, but there may be some unknown ones. But if we use the raw trajectory, we can just keep all the information, keep it as it is there. That's the that's the source behind these two ways of representation. And then we're adding attributes of socio-economic context, which is the surrounding areas like land use, population, transit accessibility, those kind of things. Those data we got from travel survey data and other geographical data like land use or road network. Once we calculate all kinds of things, we aggregate all things as at the spatial level of public transit catchment area. So that means our regression analysis is done at the transit catchment area. Why we are doing this? Because there are over 17,000 transit stations there, meaning we partition the space. We partition the Shenzhen, the whole city, into 17,000 small areas, which is a very small and fine unit. And this spatial scale is even finer than census tract. So our results is for sure finer resolution than most of the studies using census data. So then we put everything into this kind of regression analysis to look at the spatial difference. The spatial, just to emphasize, spatial unit is transit catchment area. So the input, we have contextual attributes, which is about land use, accessibility, people. And then we have those activity patterns, as you can see here. This generally like two types of representation, indicators, and then road trajectory as footprints or graphs. And then we have the other parts, the dependent variable, which is income, because we want to know what's the relationship between socioeconomic attributes and activity patterns. We put everything into our regression model. There we're not just using one type of regression model, we use many, because we don't really know what type of relationship between these two, and we don't want to make very simple assumptions. Therefore, we tested many to find the best ones to represent it. And as for the results, first, the comparison of regression models. We found out for different type, well, we did different types of regressions. I mean, using only activity features or all catch attributes or something, or different types of representation of activity patterns. We found out generally random forest gets the best performance, meaning that, well, it's much better than this linear regression. So it kind of proved our assumption that the relationship between mobility and activity patterns, socioeconomic features, is far more complex than a simple linear relationship. And then we also compared the two types of representations by indicators or road trajectory. We find out because the road trajectory has very special data structure, which is image type. So we used the neural network model to do it. And we find out in general, this kind of GCRN graph convolutionary recurrent network produced the best results there. Well, it's unbelievable. It might be some overfitting there, but it really gives the best results there. We didn't do much on kind of adjusting the parameters to reach the best, but generally we did several rounds of experiment to test, and the result is kind of stable. It always comes back with higher result, more accurate predictions, meaning the indicators we define for mobility patterns is kind of is not sufficient, could not fully capture the travel activity patterns. In the future, we need to find a way to really remain full information of trajectories, in other words, there are more patterns to be extracted from the trajectory. In terms of the influential factors, thanks to the current development of explanatory AI, we're able to look at, we are not dealing with a black box now. We can now look at the importance of attributes in these machine learning models. And you can find out this first, the one with the highest highest influence and impacts is the contextual attributes, which is really about locations rather than activities. From there, we can conclude that there's a level of residential segregation, and just like London, the high-income people, they occupy the best place. They get the best resource. And then the second part is really about mobility indicators. You can find out that coincidence is not, this is not really coincidence. This is the influential level. It's just minimum, just over minus or below zero there. Some are positive, some are negative, but still it's kind of minimum, which shows that there's no considerable difference among different income groups if they use the public transit. And it's a surprising result for us, which means that people using public transit, they don't really have a very different activity patterns. There's not so much inequalities among them. This is good, but it's a surprising result, hard to believe. So to further approve our findings, we use the census data to find out if disparities does not exist in public transit, then where is it? What's the cause? We compared public transit users and private car users, and we find out actually really it's like among this, like within this one type of like transit mode, like public transit, indeed there's not so much difference. The difference is really like between different travel modes. For instance, public transit and private cars, you can see that there's an income, there's a mismatch there. So from there we concluded that the disparities is actually more likely caused by unequal access to transport infrastructures and the modal mismatch rather than income gaps there. In other words, the positive parts of our research, of our findings, we found out a well-collected and efficient public transit system may alleviate the issue of transport-related social inequality. So it's good to be able to plan a good public transit system there. It will solve the inequality problems. And then a summary from this research, we find out individual patterns can be extracted from automatic location data. This is an advanced method. This is one step further. However, mobility data needs to be in very good quality and quantity. Social attributes are missing there. This is a constraint. So we still have to use survey data or other geographic data to match up these parts. Machine learning and deep learning models can better capture the complexity of human behavior. And this has been proved in our research and other researchers. And compared to accessibility measures, the analysis is more difficult to interpret. However, the notion of explainable AI transforms the black box to gray box, making the result easier to interpret. So follow on this project, we are doing more on this inequality tackle these inequality issues using data-driven approaches, which is really our research interest on data-driven approaches. We are looking at multi-source data linkage. For instance, in the work I just presented in Shenzhen, we are linking survey data with automatic data, and we are looking at other type of data sources. And we try to address data justice in the developing countries, because we find most of the case study were presented in my talk and also in previous talks are in developing context. There's really not so many data or case studies existing in the developing context. With the new measure, we need new measures of inequality and also spatial temporal analysis and models to address the problem. And our application is about mobility and transport planning. We should have more diverse applications, for instance, looking at mobility emergency service there. Like what we're doing here, we have some projects with London ambulance service. Here, if you want to know more, you can contact me or write to our group. a broader research agenda, which is beyond the research within my group, and which is the big directions we want to go. You will find out if we are the title of my talk, exploring, because I really think we didn't solve the problem. That's why I didn't use the word tackle. And we're just at the beginning. Identify this kind of inequality is just the beginning to find out the problems. And to solve the problem, we have to look at equity, which is a solution to address the imbalanced social system, to give people some support, allow them to get the opportunity, to access the opportunity. That's a solution we should work out. That is to tackle the problem. And further from there, we have to eventually look at justice, which is an even longer term goal we should achieve, we should aim for. And because justice is not just about the imbalanced social system, it's also about fixing the system, not just giving people the support, and also adjust the system to provide equal opportunities to people. There we can lead to a long-term sustainable and equitable access for generations to come. Okay, I don't know how much time I use, but I think time is almost running out, so I have to stop there. The last page, I give the credits to all the team there, and I leave the contacts of myself and also my team members, Chile. If you have any questions about technical detail, like setting up the kind of machine learning models, especially, you can write to her or you can contact me. That's the end. Sorry, I hope I didn't overuse the time.
Yes, very good timing, 9:43. So we still have 17 minutes until 10 o'clock. So we have time for questions. Again, thank you very much for the very interesting and informative presentation. And now we're going to open the floor for questions. If you have any questions, you're welcome to unmute yourself and directly ask questions. You're also welcome to put your questions in the chat box if you want. Okay, anyone who would like to go first? There's one question from Zhang Peiqi. I would like to ask, has this paper using deep learning and interpretable AI being published? I really want to know more about these new methods.
No, it's not being published. It's still under review, but we hope it could be published soon. And if you want to know more, if you're interested in this part, you can contact me directly. We can share. We're happy to share more details.
Thank you. Next question. There's from Yan Liao. You can unmute yourself and ask.
Yes. First, thanks for very interesting presentation. I learned a lot from this short presentation. So my question, actually, I have so many questions, but I will pick maybe 3 of them. So first question is about how do you consider debiasing emerging data sources? Like every time when we use emerging data sources, like people will say, okay, the population is not representative and the data source is not kind of fully validated against some conventional data source. Like we always face this issue, and how do you consider this in your future research agenda? This is my first question. The second question is about, so you present those interesting studies using advanced methods, revealing interesting mobility patterns. But I would like to know, like, especially in the field of mobility inequality, how do you think about providing solutions from revealing patterns? This is my second question. The third question is about how do you think about communicating the policy relevant like findings using deep learning and those new methods? Like I understand that there's a big trend of explainable AI, but still you said that in the first part of your presentation, the indicator that has been widely used is simple and easy to communicate. And how do you think about those capability of communicating using those advanced methods? Those are my questions. Thank you.
Thank you for this questions. Really good questions. I didn't expect my talk to be so many questions, but those are interesting ones. So the first one, I think, is about data bias. I think everybody doing big data research has these problems, and also quite often my PhD students come to me saying the data quality is not good, and then I always tell them that if the data is perfect, then there doesn't have any needs for our research anymore. My answer is that I think all data there's no perfect data doesn't mean that data is not useful. Data is always used for limited applications at limited spatial. Like the first thing you should consider is really about the spatial temporal resolution of the data. Like, for instance, if you are using remote sensor data, you're capturing the landscape. If you only have the resolution, give a simple example. If you only have the spatial resolution at 100 meters, you can't really use it to detect humans. So you can't really use it to do any kind of social research. I think you should, the first thing we should really looking at the data itself, looking at the spatial temporal resolution, and we will have a basic understanding, like certain level, because my expertise is really in transport planning and urban planning. So out of this, I can't give suggestions to other type of applications, for instance, like physical geography type of thing. For instance, urban planning, we have the planning at different spatial scales. We have strategic planning, and we have zonings, and we have strict street layout planning. We know that what kind of spatial temporal scale is needed for these different levels of planning. So you have the basic understanding there. You know that how can we use data? How can we do it? And second, even though the data bias, this is about data quality itself, and then we come to the second part. So we try to do, we can still extract some information from the data. So the second stage is not about the data, it's about the information there. You will find out, even though we are talking about individual level data, when we extract patterns, the pattern is aggregated at certain spatial scale. So even though there are bias, there are some problems with the data. If we have plenty of data, and if we have got plenty of samples of data, we look at average of certain locations, we look at average of certain population groups, we can still achieve a meaningful patterns at a certain level. And then we're moving on further on from analysis to models. And then we can use models to test that, even though for instance the flow matrix is not a complete one, we can only cover certain population groups, but the produced prediction result from spatial interaction model may be still very close to the full population. So there are different stages, different levels you can look at to compare data quality. Well, it might be my answer is really kind of not very well structured, because I really have a lot to share, but I didn't expect people to ask in this way. My ongoing projects, the one I mentioned before, is about real trips. Real trips is really focusing on data bias. It's really about addressing the variabilities at different level for different types of applications. If you Google my webpage, you'll find it. The short name is, I can type it here, is about, so the name, okay, so it's this one. You can find more information there. And your second question is about how to address this, the solutions there. I think I kind of mentioned our future agenda, research agenda, in the last second page, in the equity and the justice there. For these two parts, we are currently doing two things there. The first about equity. We're trying to look at from the demand level. We're trying to detect different travel modes from the emergent data sets, try to understand people's choice of travel modes, like as different areas. For instance, taking the example of 15-minute cities, in London here, we're trying to promote active travels. Active travel is mainly referring to like walking and cycling. In that case, we need to, from the emergent data sets, we're looking at demand for cycling and demand for walking and what kind of urban infrastructures or like residential locations or other opportunities we can provide in these areas. And in this area. So we really try to address it from the demand perspective and also from spatial organization perspective. Like we know there is demand, so how can we adjust the spatial organization of resource to meet this kind of demands? So this is one of our solutions. Another thing we're talking about justice there. I've said justice is a very difficult topic. Because it's not just it's not pure computational, it's also social problems. It's not something we're really good at. There we have a project going on, PhD research going on, looking at the justice, the data, digital justice problems in developing countries, in Kenya. Like giving you an example, like we know mobile service becomes more popular. Everywhere there's a digital transformation globally, and we try to, I think it already started. Like we try to make decisions based on data we have. However, some people's voice is not listened because their data, because they don't produce the kind of data, they are not covered by our data sets. So when we address demand, we can't address their demand. So there's justice problems there. So this PhD topic is really looking at the digital justice, data justice. So this is the solutions my group, I'm trying to give there. Two relevant research projects. If you are interested, you can get in touch. And the third one is even more difficult. I'd say not from our collaborations with industry partners. I'd say public engagement, knowledge transfer from academic to industry is the pathway towards making those technology acceptable by the practitioners and the end users. We find this is a general answer. I find it very difficult because when we for instance, when we communicate with them, the ambulance service, they prefer to use the most simple methods, for instance, linear regression, because linear regression is kind of transparent box. They can understand the relationship between each individual variables and how they influence the final results. But if we give them neural network methods, it's a black box. Especially for medical service, they can't bear any uncertainties, so they can't really accept it. And for people making policies, it's also difficult because they prefer accessibility as a very simple measure. So they can use numbers in their policy papers. Like they can't accept things like importance factors in their policy. So I have to say like knowledge transfer is the way to make it happen, but it's still challenging. It's still on the way. So that's my answer to your three questions. Maybe didn't quite address your questions. I can only share my insights, not really the answer. Yeah, so we can chat more if you're interested. Just keeping in contact.
Yeah. Thank you so much. I think your answers are really good. Yeah, I learned a lot. Thanks again.
Thank you.
Yeah, thank you very much for this very detailed answer. And let's move to the next one. I think it's Bing Li. Can you unmute yourself?
Hi.
Hi, Dr. Chen. Thank you very much for a very interesting talk. this is the first time actually I attended the webinar, and class is over, and I felt that this is a great treat. And so I learned a lot, and it's very encouraging to see this going on. Now I have some probably more technical question, and for you to consider and maybe to clarify. The first question is about your study unit, the transit catchment area. You choose 1 kilometers. And I want you to, I want to see the rationale for that 1 kilometer buffer zone. And also you're using a buffer zone, right? A buffer zone is sort of evenly a circle instead of a actual distance to the bus station. And that's one. And the second thing is also around that, the unit of study, the time resolution. How do you aggregate them? Is that in a day, a week, and half a day? How many hours? And so I mean, that would be your dependent variable, right? The dependent variable is the accessibility. That's something that it's not quite, because you didn't list the equation on the screen, so I don't see what's the dependent variable for your regression. And for the now you have SUV, BSVR, you have linear regression. It depends on. So I suppose your dependent variable is a some kind of it's not a count, right? It's some sort of that's fine. I let you articulate. And then for your model, I'm wondering, now you have the X and Y centroid included, and I think that one of the audience already indicated that your Y component is super influential. I was wondering that now the spatial component is not just the absolute location, but the interactions, right? So the interactions of your catchment units, and how do you account for that? So that the spatial interaction itself between geographic units, and then the space and time interaction. Now that's difficult, a little bit more difficult to do, but it's now, I think that's technically available now. And then finally, there's two more. You use a graphic to indicate there are disparities. And say instead of use statistical test to show the groups are different, I think that you could use some kind of statistics to make it more rigorous. Right. Mm-hmm. So you say, okay, not just showing it, but say I'm going to do a t-test or some kind of test, ANOVA or something like that. And then finally, it's the model fit. The model fit, we want to see not only just how best it fits the data, but you want to divide them to see your test data out of sample fit. Particularly when we deal with the machine learning methods, it's hard to infer, make conclusions. And so those are my questions, and I want to see clarifications or your insight on those. Thank you.
Thank you, really, thank you so much. This is very insightful. I can already expect we got many. We can get comments from reviewers, and they may address these problems as well. I think some of your comments is really suggestions and really useful. We'll consider it. I try to answer your things. Maybe I didn't fully capture your question. So about the spatial units, the 1 kilometer buffering areas is really it's actually we decided based on two parts. One part is the literature review, because we are not the first one invented this. There are many papers, some of them using 500 meters or 750 meters or 1,000 meters. There are different ways. We find there are always different choice there. So we choose 1 kilometers based on some of the studies. people's experience, like the paper published in Shenzhen before. This is one part of the reason. The second part of the reason is from the survey conducted in Shenzhen. This is not in this research, in other relevant papers, like acceptable walking distance, like connected distance about 1 kilometer. That's how we choose it. Well, it's really a matter of choice. And in terms of temporal resolutions for the graphs and for the road trajectories, when we combine them together, we do them using hourly. So it's 24 hours. And those kind of indicators is calculated based on an average day, representing average mobility patterns. And those accessibility, on the other side, the contextual attributes we calculated from land use, from accessibility, densities, is the data from the same year. So we try to keep all the data sets, the temporal parts, matched with each other. So that's the saying. And in terms of mobility patterns, I have to confess that some of our indicators, for instance, we measured the mobility indicators at individual level. For instance, the activity extensity is about the area which people has traveled. Say if we travel to 5 locations, we will calculate the area of these 5 locations, say maybe to look at it, how big is the activity area, activity space, and then we aggregate individual people into this basic spatial unit. So people who linked to this spatial unit, they will be aggregated together. So we are calculating an average mobility pattern based at the spatial units. In terms of spatial interaction, therefore, our mobility patterns really capture individual behaviors, not really like the behavior of locations. So the spatial interaction of 2 locations is not really specific addressed there. And I've said because we look at trajectories, so it's from one location to many locations. So there may be a bit of it in it, but we don't have an indicator talking about interactions straightforward, explicitly calculated. But we agree it's important. Not in this paper. In another paper we're currently working on is looking at multi-scale analysis. I think there is more important to address the interactions between locations. And also we have another work looking at the cross-boundary trips. So this is important. So looking at which areas has more stronger interactions than the other pair of locations. This will impact to city integration. So we didn't address it explicitly in this paper because of the methodology design, but it's good. It's a good suggestion. We will address it later. In terms of the testing data and training data, I understand that parts. Yes, we probably should improve our models. That's why in my talk, when we say the neural network models, the R square is about 0 line something. It's way too high. It looks like overfitting problems there. So this is I can only say that is future work we need to work on, but I can't give you a very good answer here. And just say thank you for the suggestions. Thank you for your comments.
Thank you very much.
Yeah, once again, thank you, Dr. Bingley, for the very insightful questions, and Dr. Zhong for the in-depth response and comments. And Dr. Lee, do you have more questions?
No, thank you very much, and congratulations.
So looks like we're already 5 minutes past time, and I think it's time to wrap up the discussion. And I don't have a question, but maybe just a comment or remark. Something I'm not sure about if you pay attention to American politics, especially during the during this time. Anyway, I think we will have some discussions later. But I think Dr. Zhong have some other appointment that has to go. So thank you very much for attending. And this is our last webinar. So I think later we have another one, GeoAI. So you can follow the CPGIS WeChat group. And so looking forward to seeing you all in the future webinar. Take care, everyone. Bye-bye.
Yeah, thank you, Dr. Chen. Dr.
Thank you.
Bye-bye.
Thank you, everyone.